A very warm welcome to you on behalf of AI Policy Labs to our podcast series Role of Technology and Artificial Intelligence in Achieving SDGs. My name is Naman Singha. I'm working with AI Policy Labs. And just to give you a brief description, AI Policy Labs is a global initiative which has been set up with a vision to explore emerging technology and assess the impact of intelligent automation and digitalization and AI on policy making and governance. Our primary focus is to explore the role of AI for public and social good, with a vision to build discussions on important issues such as what role AI plays in achieving the SDGs, or will the new generation of technology take us closer or away from our global goals. We have launched a program on AI and SDGs, which will comprise a podcast, webinars, expert opinions, and reporting articles to be published on our global channel to be published in partnership with the Graduate Institute Geneva. So, this podcast series is being conducted with an aim to understand the potential of AI in achieving SDGs. The focus of today's podcast is on SDG 2, which is the goal to zero hunger by the year 2030. To introduce our expert today, we have with us Dr. Ernest Mwebaze. Uh, Dr. Ernest Mwebaze is currently the head of the AI and Data Science Research Lab at the School of Computing and IT, Makerere University in Kampala, Uganda. It is a lab that leverages computational techniques and AI to address local problems in developing countries. Also a lecturer and researcher at the School of Computing and IT, Dr. Ernest has previously won a Paul Grant from the Gates Foundation and a Peer Grant from USAID. Dr. Ernest is extremely passionate about improving the livelihood of smallholder farmers through the use of low cost mobile phone based diagnostic and surveillance tools powered by AI and big data. Dr. Ernest, we are delighted to have you with us today. So, on to the first question. In your view, is AI acting as an enabler or an inhibitor in achieving SDGs? And can you pick some examples from the new developments?
Yeah, thank you. Thank you. It's good to be here. So AI as an enabler inhibitor. I think AI has potential to be a great enabler in many respects. I think when it gets abused, it may be an inhibitor, but I think for us in our context here, it has potential to be a great enabler. And we've already seen some of these things, some examples, particularly in the domain where I work with smallholder farmers. We've seen technology to automatically diagnose crops, which has been built on phones and given to smallholder farmers. So for smallholder farmers, their livelihoods, especially in Uganda, where 75% of the people really depend on farming, this is a big thing if you can give them a tool in their palm that can immediately diagnose disease in their gardens. Ordinarily, to do this, they would need to wait for an expert to come from an urban area, travel extra miles, and go to their gardens and look at the crops. But with this tool in their hands, a mobile phone, they can go to their garden, diagnose disease, and then get some additional help on what to do if the garden is diseased. So this is an immediate enabler of particularly for this SDG goal of zero hunger, because then they apply intervention immediately, and then there's extra yield, and from that they get food. From food, extra food they can sell and get medical and pay school bills. So it's a great enabler for this particular SDG.
So, in your perspective, what are the recommended emerging technologies that will help in enhancing the second SDG?
Yeah, so recommended technologies. So we are seeing technology, especially emerging technologies, slowly coming into this sector. I mean, for example, AI and machine learning. While these are sort of becoming well established in other domains, in this domain, for example, in Uganda, these are sort of upcoming technologies. And I think we're already seeing examples of how AI and machine learning could definitely be harnessed for this. Some other technologies which are quite interesting, Internet of Things. So this is very closely related with machine learning and AI. And basically the idea that these devices and objects can be connected to the internet and can gather and transmit data is is quite a big promise for AI in reducing the burden due to this SDG goal too. So the way it can work, for example, is putting sensors in fields that can tell you when to irrigate, what's the quality of the soil, or give you some surveillance information about disease or pests, and these kind of things. So these and some of these things have been trialed. Um, Remote sensors connected to other devices and can produce information almost in real time. So that's one big thing. The other things, other sort of emerging tech include things like big data, which is sort of old, but it's still becoming I think we've not seen the full potential of big data. This idea that you can get data from multiple areas and multiple devices. For particularly for poverty, you need data from satellites, for example, maybe data from people on the ground, the farmers in the field with their mobile devices. You need maybe data about where pesticides are, where the agriculture experts are, where what quality of soil you have in a particular area, what's the historical um, knowledge of the field where you're growing things, what is the information in the crops that you're growing. So all these things, if there are ways of collecting this data and amassing it, movement patterns, all these things help in creating a picture that you can use. You can use artificial intelligence or machine learning to build over this data and do predictive analysis. Um, other other related technologies, for example, cloud and edge computing, I think these are also hold great promise. The idea that you can abstract away all this infrastructure you need to build and build this knowledge and data processing in the cloud or on edge devices, it has great promise for working in this sector. And I think one of the biggest enablers for all these technologies is sort of internet. So the idea, especially 5G, where you have high speeds for data and internet, you can stream video, it has a lot of potential for collecting real-time data and transferring it, transmitting it really fast, enabling cellular technologies that maybe we have not seen the full potential currently, and also the growth in technology in smartphones that they keep improving, screen size, battery, all these things I think have huge potential in positively influencing this particular um, SDG goal too.
So that was a very interesting uh, observation that you told us, Dr. Ernest. I think you sort of already answered the second, third question, but do you have any possible measures and recommendations to propose to enable efficient use of AI in achieving the second SDG?
Yeah. Thanks a lot. Yeah, I think, well, I can give some recommendations from the work that I've done here in Uganda, especially working with smallholder farmers. They may not be conclusive, but I think from my experience, one of them is this idea of a bottom-up development, a sort of grassroots development. So the idea that the solutions are built from the ground up. This is so important because in my work in trying to improve the livelihoods of farmers using AI, I think we've done several types of interventions. But the ones where we've started from the top, you would have sat in a lab, thought of a problem, thought it was a good problem, built something that looks like a solution and taken it to deploy it down. But these ones have always not really worked well. You sort of get you really don't have the the right sort of specs for building this problem. So actually building from bottom up, I think is very important. So going down to the ground and understanding exactly what the problem is. There's so many facets of a problem. When you look at it technologically, it's one thing. But when you get to the ground, there are sociological aspects to the problem. there's cultural aspects to the problem, and etc. And so that's one recommendation. The second recommendation, which is connected to that, is context. So the context of the problem is quite different. So getting a solution from, um, for example, from the West and directly applying it, for example, here in Uganda, while it's, technologically it looks like the right thing, maybe you've optimized the bandwidth consumption that takes less, optimize it for a cheaper device. These look straightforward, but when you get to the ground, then you find the context is quite different. For example, the cultural appreciation. Um, some of the examples include things like languages. You think maybe this app works in English, but actually when you go down, you find that maybe you want to make the display more visual so that it appeals to more people. There are things to do with age that come in. So all these contextual differences are very important to consider when building these technologies. And we found that they're extremely critical for uptake. I think the other thing is, of course, something related to that is that you always want to put the user first. So you sort of develop with the user, and then think of the technology. I think the temptation is always to go with the technology. What's the cutting edge technology? What's the latest tech? What's emerging tech? And then you do this, and then you take it down. But sometimes you want to start with the user. What's the user's level of uptake, and then you build a suitable solution. Maybe the last recommendation is has to do with evaluation and monitoring. So how do you assess that these technologies are having impact? I think this is something we've fought with our implementations. So this is a hard thing to do, and I think it needs a different way of looking at impact to evaluate these technologies. And I think what we found that impact is extremely a fluid thing when measuring these technologies. For example, some of the trends we've seen that when you introduce technology, a small farmer, give him a phone, he has some technology on the phone. In our case, it was AI to do diagnosis of crops. He can do it in his garden, his neighbor's garden, the next person's garden. What we realize is that eventually this person leaves farming. It's a weird thing. You always think he's going to, have a better farm, a healthier farm, grow more crops. But then they actually leave farming. And why they do this is because they can sustain their livelihood by supporting more farmers. So it's easier for him to create a business around this and support more farmers than take the time to sort of cultivate more and have a bigger garden. So you see different levels of impact. That's just one example. But there are several other sort of facets that are not necessarily visible at the start of a deployment, but that you sort of see towards the end. So yeah, I think those would be my sort of top recommendations.
So those were really insightful recommendations. Uh, On to the last question. Do you think investments in the field of AI further increase the competitive disadvantages of those too poor or too remote to access expensive hardware such as computers and internet connections?
Yeah, that's that is a tricky one. Yeah, so introduction of technology has always sort of caused this big divide. Uh, so it's uh, something to definitely consider. So I think maybe in some aspects it depends on the stage of the technology. So for example, currently we've seen a lot of work in AI, which has sort of been on the prototype stage. And when it's at the prototype stage, you get, I don't know, 10 farmers, 20, 50 farmers, given this expensive technology, and then they seem to have better outcomes than all the other farmers. And mainly because it's at a prototyping stage. But I think for deployment, when you roll these things out, then you sort of you start, when you want to actually deploy these things at scale, then you see that this divide is actually smaller. It's a smaller divide that's created by introduction of this technology and AI. And what we've seen is that there is always a trickle down effect. Now, for example, in artificial intelligence, you have a big component of AI is data. The big component of data is collecting the data, making sure the data is clean, is valid, it's actual data from the ground, and so that you can build a model or an artificial intelligence system that actually works well and is accurate and does what it's supposed to do. And what we're seeing is that, there's a bigger move. Once you deploy at scale, then collection of this data involves these people who would potentially be left out by technology. So you need to get the data from them in some form. And I think there are big movements now to say, okay, if you're getting data from a smallholder farmer down, what is his compensation? How do you compensate him for the data? How do they collect the data? Maybe they need to collect really good data. They need good equipment. They need a phone, for example, to collect good images. They need some training. They need some data. And so these trickle down effects, while you're deploying a big AI system at the government level, the people need to collect the data down on the ground. And so you still get these trickle down effects of investments in AI. And so I think that's one big thing. I think at scale, these differences sort of go down. But I think to mitigate it further, I think there should be sort of better design of these AI systems. So the design from the get-go should be designed such that it doesn't create this big separation. I think that would be a key thing, especially when thinking about rollout. How do you scale this thing out? So I think a lot of investment, or most of the investment that should come in, but I think one, it should influence the design of the system, that people who are on the ground, that there are no people left behind, basically, because the system requires input from all these people along this chain, and so that each sector of the chain is not left behind. So I think that better design sort of mitigate some of these problems.
So those were some really insightful and understanding and perceptive views. Thank you so much, Dr. Ernest, for being here with us today.
Welcome. Thank you for having me.